How's it going, mathletes? So we're in chapter 2. Congratulations on finishing chapter 1. And so we're going to talk about relations and functions in this chapter, and more specifically linear functions. So there's a lot of vocab. So I just made a page with all the vocab on it. We'll talk about it kind of as it goes. But if you want to pause this or take a screenshot of it, you can. It's also in the book too. There's a few actually that aren't in the book. Let me just point those out. Let's see, relation, function, domain, range. Yeah, I think those are the main ones. So those ones I just wanted to put in because all these other things talk about, the functions and domains and range and relationships and so forth. So I think those are kind of foundational to define the others. All right, now I think a lot of this will be review for you, but we'll see. I think we're starting to get in some territory where, you'll probably recognize some things, and then there'll be some things that you may not have seen before, or maybe you forgot about, or have seen them in a different way, or something like that. All right, so we're talking about functions and relations in this chapter, right? And so I'll go back to this just for those foundational ones. So a relation is where you have two sets of values, inputs and outputs, and those inputs and outputs relate in a certain type of way or correspond in a certain type of way, right? So for each input you have an output, and so forth, and so or you may have more than one output for an input and things like that, and that'll kind of determine whether or not it's a function. So a function is a relationship in which there's every input is paired with a particular unique output. Okay. All right. So coming back to here, so there's different ways of representing relationships. So remember that relations are just pairs of numbers, right? Or sets of numbers that relate with one another or correspond with one another in a certain way. So I have some different examples here because these can be from any walk of life. Like I have here hours and earnings. So, that could be your job, right? How many hours you work versus how much money you make. Absences versus your grade, right? How many absences do you have in class versus what's your overall grade? And then I have one that's selling price and units sold. So, if you're in a business, what price are you marketing an item at versus how many units of that item are you selling, right? And there's a relationship there. So, and there's all kinds of things. You can talk about sports, you can talk about, weather, anything really. And there's almost, the possibilities are pretty much endless in terms of where you can find relations in the real world. All right. So a few different ways to represent relationships. You have sets of ordered pairs, right? So sets of ordered pairs are where you have an input, then an output, right? A lot of times it's X, then Y, right? And so that's what it'll look like is two values separated by a comma in parentheses, right? And then each ordered pair is separated by semicolons usually, right? That's usually how it works. So X, Y, where X is your input, Y is your output, right? Okay, then you could have a table or a chart, right? So here we have hours in one column and earnings in the other column, right? So if you work 20 hours, you make $200, right? Or something to that extent. Here we have a horizontal table instead of a vertical table. So now the inputs are in the first row instead of the first column, and the outputs are in the second row instead of the second column. And then here we have a T-chart, which is basically a table, but maybe not as formal. Maybe it's just X and Y instead of the title. And anyway, so those are a table or a T-chart, right? Notice how these correspond. So this one here, this set or this relation goes with this relation, and this relation goes with this relation, and this one of course goes with this one. All right, same thing with the mapping diagram. So a mapping diagram you may or may not have seen before, but that's where you have your inputs on one side, your outputs on the other. Then you have arrows that go from each input to its corresponding output. So 20 corresponds with 200, right? 25 corresponds with 250 and so forth, right? 35 is the input that outputs 300. Okay. Now, one thing with mapping diagrams that's kind of interesting is you always put the values in order, right? And so so what happens is sometimes you get this crisscross effect, right? So in a table, you don't necessarily see that, right? In a table, you don't have, usually a lot of times you put your domain or your set of inputs in order from least to greatest, but then your outputs correspond, and so those may or may not be from least to greatest, right? So in a mapping diagram, you always list least to greatest on either side, and then the arrows correspond, and so you'll get some, crisscrossing effect, which kind of tells you something about the relationship. And we'll talk about direct and inverse at some point, but that's kind of what it can kind of point to. All right. So those are the ways you can represent relations. Oh, one other way, almost forgot. We have also graphs, right? So graphs are another way to represent relationships. So now with graphs, or you could have a set of points. If those are finite points like that, that's called a discrete relationship. Okay. So where you just have a set of points. If you have points that connect all the way through, that's a set of continuous. So that's a continuous relationship, right? Where I don't have to pick up my pencil to trace this graph, right? I could trace it all the way through. Now, then you have these that are kind of hybrid, right? You have kind of part continuous, part discrete in terms of their, they kind of jump around. They're not continuous. I have to take my pencil off the page, but it's also an infinite set of points, right? Because between any 2 points on a number line, there's an infinite amount of points. Like think about if I was going just between 0 and 1, I could say 0.1, 0.11, 0.111, 0.11111, right? And we could play that game forever. 0.01, 0.001, 0.0001, and so forth and so on. Okay. All right. So, and on a graph, usually the x-axis is the input axis or the independent axis, and the y-axis is the vertical or the dependent axis, right? Okay. So inputs on the x, outputs on the y. All right. And remember that each point, and I'm sure you all know this, but each point corresponds with an input and an output, right? So like for this point right here, the coordinates would be 2, -3, right? So we could trace any of these points and make them into a set of ordered pairs, a mapping diagram, a table, right? When you have discrete, you can do all those things. When it's continuous, you can't really put it. You can put some of the values in a table, but these by nature are finite, right? Are discrete, and so the ones that we see here are basically discrete relations. And if we were to use a continuous relationship in one of these, then we would have to we wouldn't be able to list all the points, because in a continuous relation, there's an infinite amount of points. All right, hopefully that all makes sense. Let me know if you have any questions.